Okay, let's continue with example 2. Okay, so let's take out all the information. Okay, so our x is our x bar pula. Our x is, based on this example, 10. Your sample n is 300. Okay, so dia kata apa problem dia? So we can calculate our p hat, which is 10 out of 300. Okay, or 130. So claim dia 5%, but the proposition is less than 5%. So the word less is good information that can help you to write hypothesis alternative. So we start with the step 1. Okay, remember, for step 1, we have to state the rational and alternative, because this one is about proportion. So our p is less than 0.05, and our rational, of course, greater or equal 0.05. Okay, for second step, sketch this, and since our alternative is less than, so our rejection region will be at the left tail, and this one is left tail test, right? So our aim is to get the critical value for this. Okay, so our critical value is here, of course it will be negative. So macam biasa, kita tengok pada table normal distribution. Since is the area is 0.05 and the value is same, the significance level is same like in the example 1. So of course we know that this value is negative 1.645, right? So that's our critical value. So take a look at step 3. We need to calculate the test statistic value. So apply the formula p hat minus p over the square root of p q over n. So you just substitute the value. You know that p hat is 1 over 30. 1 over 30 minus your p, our p is 0.05, so over the square root of 0.05 times 0.95 over our n is 300. And please try to find the test statistic value using calculator, and the value supposed to be, so kita calculate sama-sama. Okay, so 1 over 30 minus 0.05 by we divide by the square root of 0.05. You need to careful, because sometimes kita boleh jadi silap kira. So Bismillahirrahmanirrahim. Oh, error. Back. Okay. What happened? Oh yeah, because there's no delete. Okay. What is your answer? My answer is negative 1.3245. Okay. So if my calculation is true, okay, please check your answer. So for step 4, we compare the value we get in step 3 with the critical value at step 2. So kalau saya boleh copy this one. Okay, copy, I put here. Shit. Macam mana? Wait ah. See. Step 4. Okay, kalau saya copy, paste. Okay. So my calculation is step 3 for test statistics. The value is negative 1.3245. So we compare that value with the critical value. So they are supposed to be somewhere here in the exceptional area, negative 1.3245. Sorry, betul. Okay. So here is negative 1.3245. So what can we say? In the decision, we exceptional in this. Yeah, very simple. Exceptional. So just write exceptional or fail to reject exceptional. Yeah. So for the final step, we need to answer the question. Does this outcome provide sufficient evidence? So since we read exceptional, so this outcome does not provide sufficient evidence. Alright, so you just write that sentence. This outcome does not provide sufficient evidence. Okay, for me that's enough. So but you are allowed to write until the last word, right? So yeah, we finish at the hypothesis test for one population in proportion, right? So let's continue with the last part in one population hypothesis test, which is another way we can do hypothesis test, which is called p-value approach. Okay, actually there's no much difference between the critical value method. I mean, like what we have done before. In this part, p-value approach, the only difference is at the step 3, where you compute p-value based on computed value of test statistic value. Right, so this one, the step 3. The first step is you state the statistical hypothesis. Step 2, you identify the significance level of alpha. based on the question. And the step 3 is you compute p-value based on computed value of test statistic. Okay, and then step 4 and step 5, yeah, still the same. Establish the rejection region and make a decision. Okay, what important thing in the p-value approach, if p-value is less than alpha, yeah, you reject H null. If not, you accept H null. That's all. Very simple. So let's take a look at example 3. Okay. So, in example 3, the life in years of LED light bulb is known to be approximately normally distributed with standard deviation 0.8. Okay. So remember, they give you the information about sigma. So we need to apply Z distribution test, right? Okay, the question is there evidence to support the claim that LED lifespan exceeds 6 years? Okay, recall n equal to 100 and x bar is 6.3 years. And they ask you to use p-value approach and your alpha is 5%. So, if I were you, I will highlight this one. This is very good information. They give you standard deviation. Habis pen. Oh, please. Okay, so sorry, I stopped first the second video, and I will continue right after this.